Today we will talk about how to convert a time series data into phasor form, any rectangular value, how we can convert it into phasor form, and then from phasor form how we can convert it back to a time series value. Think about this cosine wave which starts at 0. At 0 point, this cosine wave has its maximum value. Say for example amplitude is 1. Now if this is a voltage, if this is an AC voltage time dependent, then we can express this Vt in terms of omega t, something like that. Vt is equal to cosine of omega t. Now if it has an amplitude 1, then we can put 1 cosine of omega t. If this cosine wave starts at 0, then cosine of 0 is equals to 1, right? Now we can also express this in another form, which we call like another phasor form, like 1 angle 0 degree, right? 0 degree, and this is false because this starts with 0 and this is a time dependent wave, like so we call it omega t, cosine of omega t, and plus we add a 0 here because this value is, for example, at this point there is no phase shift, right? For the cosine wave at angle here, we say the value is 1. That means no phase shift. Now, sometimes we will see that there is a phase shift, for example, 30 degree or 60 degree. What does it mean? Lagging and leading, right? If we say this is plus 30 degree, that means this is leading 30 degree. That means the wave is starting from some value. Okay, we will call it 60 degree, right? It will be easier because so this is 120 degree. This portion we call it 180 degree. So is portion, how much is the value? Like 60, 60, 60, right? 360 is 180 degree. Like so this one, for example, here. So instead of starting from this point 0, it's starting from somewhere here, and this point is 60 degree point. Anyway, in that case, we convert it into what is the value then here? We call it 60 degree, right? We need this conversion in solving the problems in an easier way. That means this value directly comes here, and this amplitude directly comes here. And this is how we convert a time-dependent series into a like polar form. We call it polar form here. This one we call it polar form because in this diagram we know that this is an imaginary line, right? This line is imaginary and this line is real. Now we can express this circle in two different ways. One is rectangular form, one is in polar form. So if we want to solve any electrical circuit, okay, this one we can express, for example, this angle is theta. So we can say it has some real value plus z, some imaginary value. Okay, so either we can express in this form, and this is called rectangular form, and this one can be converted into polar form. That means some value and some angle theta. We call this one as a polar form. Now, how we get this polar form, we should already know. So P is equals to square root of RE square plus this square, right? And we already know how we can determine this theta value. Theta is tan inverse, and so imaginary part by real part. Although we have our calculator, we can easily convert this rectangular form into polar form. Now, why we need this conversion? Again, I'm telling, whenever in any circuit you will see the time-dependent values are given, you can convert the time-dependent values into this polar format and then solve the circuit easily with phasor algebra. You know, algebraic equation, just use phasor algebra. So, for example, if you have a circuit, resistors here, and then some inductor here, and then maybe one capacitor here, and there is a voltage source given here. This is VT. Say this is IST, and you need to find out VT here, V2. Now, how will you solve this if these values are given in terms of T? That means time series, right? Time series value. The first step is convert these things into some another form, like we call it, this is a vector, right? So I'm putting an underline here, underscore kind of thing here, so that this is a vector. At first, you have to convert these values into vector form and then solve it using phasor algebra. And then finally, the unknown quantities, for example, I want to find out this V2, V2T equals to what, right? So we have to basically find out what is this vector value V and then convert it back to this time series value. Is there any question so far? I think you already know. I'm just refreshing your memory. So in terms of V here, and this one is, say, I. Whenever I'm saying I, it has some value and some angle associated with it. Any confusion so far? Like, these things are really easy, but as it is new to you, kind of sometimes becomes very hectic to remember all this stuff. And another very important thing is, whenever it comes to a DC circuit, DC, then resistor, for DC we call it resistor in any circuit, right? Like the amount of opposition whenever a direct current is flowing in a circuit. But when it comes to AC, then this thing is not, okay, this is DC and this is, say, for example, AC. Now in a circuit, the resistance is equivalent to kind of impedance now, okay? In DC circuit, we call only DC resistance, but in AC circuit, this resistance is now impedance. And this impedance, basically, Z is a sum of resistance plus Z of XL if it is inductive, and if it is a capacitive, we call it Z equal to, for example, we have only two elements. This is resistor and there is an inductor here. What is the total value of like opposition? So R, this is L. So we calculate this in this way, R plus JXL. If it is a capacitor, we then convert like we get the impedance in this way, R minus J XC. So in your lectures, I have seen that you found the formula in a different way, maybe a different way, and that different way is something for any inductive load. If you want to find out only there is an inductor here, L, and you want to find out the amount of impedance impedance for this branch, then you got the formula J omega L, right? But if it is a capacitive branch, you have the capacitance given, then G will be 1 by J omega C. Sometimes we refer this one as a minus J over omega C or minus J XC, where XC is equals to 1 by omega C. That's the thing. Because sometimes I will tell this is XC. So don't be afraid, because this is the same thing. I'm just converting it into a different way. However, if you remember this formula and this formula, it will be enough for you. So another important thing I would like to tell you, you have already mastered your techniques how to solve a circuit in DC case. Now, almost all the algebraic theories are applied in case of AC once you convert the circuit into polar form. Okay, so far we know the impedance here. We already know what is impedance now. Now another thing is admittance. What is admittance? Admittance we represent with Y, which is kind of opposite to the impedance. Now this one we sometimes call into a different way, express it into a different way, G plus J B. We call this one as a conductance and this one as a susceptance. And this one is susceptance. But in case of impedance, Z is equals to R plus J we call X. This X could be, XL, or it can be XC. It doesn't matter. So one thing is matter. Whenever it comes to X, obviously that circuit is related to either L or C or both this circuit element. Similarly, for admittance, if you see this B element, JB, then obviously you will know that this circuit, associated circuit, is related to either an inductor or a capacitor, or maybe both, or maybe more than one of them. Anyway, this one we call resistor, and this one we call reactance. Actually, resistance and reactance. So inverse of resistance we call it conductance, and inverse of reactance we call kind of susceptance, just for your analogy. And this unit you already know, ohm, and the unit of conductance, admittance is we call Siemens. We represent it with S. So far this is the basic things. Now let's dive into a real problem and try to solve it. Okay, before going that, just another thing to be noted, KVL, KCL, everything is applicable in AC circuit analysis. like you have used in DC case. Okay, so for example, a given circuit is like this. Now we will try to solve this one. Say this one is VT. Now, one thing, even if it is written plus minus, this is given VT. What kind of source is this?
It's a voltage source.
Yeah, voltage source. I mean, what types of power here? We can
It's
like
AC power because it's dependent
AC
on
power because it
time.
is time dependent. That's right, AC power. So now we have a resistor here, we have an inductor here, and we have a capacitor here. Okay. Another thing, like sometimes you see capacitor is expressed in this way, and sometimes you see capacitor is expressed like kind of a curly another here, and this one is straight. So both of them are capacitor, but what's the difference? Do you know? Okay, so one of them is polar, another is non-polar. So, so whenever it comes into like this, so this capacitor have a positive terminal and a negative terminal, but this one does not have any positive terminal or negative terminal. So you can switch the direction in either way. This is very important in DC circuit, but in AC circuit, I think in either way you connect it, it doesn't matter. Anyway, so this one is 25 ohm. This one is L is 20 millihenry and C is 50 microfarad. Now it is given F is equals to 60 hertz and Vt equals to 50 Vt equals to 60 cosine of omega t plus 30 degree. Now we have to find out the equivalent impedance GT, and we have to find out the current. If we say it current like IT equals to what? Only one current is here, right? Now, now tell me how we find out the GT. Anybody else?
To convert,
Okay, go ahead.
you need to convert each of them into their phasor form, and then since they're all in series, you would add them all together. That
That's
would give
right.
you the total.
That's right. We will add them all together. So we first say what is the vector form, I mean phasor form of this one, right? So this one is then 60. And what is the angle here? 30 degree. This voltage. If there is no value here, like angle here, in place of 30 degree, if it is 0 or only given omega t, then this angle will be 0. Anyway, now we know that r equals to 25 is already given, but we have to find out how much is the z for L. That means XL, we call it XL. XL is equals to Z omega L. So XC equals to 1 over j omega c. I think you can easily calculate this stuff. I will not calculate it here. So once you get these three values, then your GT will be equals to R plus XL plus XC. Actually, J is already there, right? So I'm not kind of giving J here again because XL, okay, if we say now some value, we will get something like that. Some real number, say 30 or 25, plus maybe we will get some J like 8. I'm just assuming something. And this for this one, I will get say minus J like 5. I'm just assuming this value. So for the case of capacitor, you will always see that there is a negative sign associated with it here before the J. Usually, why is this? Because this J, whenever it comes at the top, then it becomes, and if we multiply this stuff like J at the top and J at the bottom, so we get J square at the bottom, right? So that makes it minus 1. So that's equal to J over omega C. And this minus is here. Now, always remember, inductor does one thing in the AC circuit, and because of this negative sign, kind of capacitor kind of compensates that. So in any electrical circuit, inductor always creates some kind of uh, positive reactance, and we add capacitor to the circuit so that that positive reactance can be compensated in some ways. Anyway, it's a big stuff. Why we use usually inductors and capacitors in AC circuit. This is one of the reasons. Anyway, once you get this GT, so once you get this GT, how you find out the IT? I is equals to V over GT. This is simple. So once you get this value, convert it into, oh, this I is basically the vector form. So once you find out the phasor form, then convert it into, say we got this one like 10 angle, say minus 35 degree. I'm just assuming. Then what will be IT? How we can convert it back to IT? Any idea?
Just be the 10 cosine of your original frequency minus 35.
Minus 35. That's right. Now, in some cases, this omega t is you have to express in terms of some real value. That means omega is equals to 2 pi f. So this one, the frequency is given here. That means 120 f. Okay. Now omega t is becomes like here. If we want to express this in terms of some other real value, then you have to express it. So don't forget to do this. If the frequency is given, then you have to write down 120 pi t minus 35 degree. Okay, this, and what is the unit here? Ampere. So in some expression, in some problem, you will see this value is not directly given, but the frequency is given, and you have to find out what is the value of this omega. And this omega, we call it angular frequency. What is angular frequency? You already know that. What is the unit of this omega? Anybody else? Can you please tell me? What is the unit of omega? Okay, so the unit of omega is radian per second. Like whenever, okay, think about this one. So what is the relationship between degree and radian? Degree and radian. So this circle, whenever we go through like continuously once here and come back here, that makes 360 degree, 360 degree, and that is equals to twice pi radian. So whenever it comes like 360 degree means 2 pi radian, and this is we call like omega equals to 2 pi rad. Sometimes we express it like rad per second because this one is associated with some frequency, right? Hertz, 1 by s is equals to hertz, and hertz like SG, I mean. Okay, so sometimes your value will be given in terms of degree or radian. You have to convert it into vice versa, right? So 1 degree is equals to then pi over 180 rad. So to 180. Okay. So the easiest thing is to remember this expression, and then you can always convert it into how much degree and how much radian you have to convert. That means pi radian is equals to 180 degree. So anyway, radian omega is the angular frequency whose unit is radian per second. That's the key takeaway from here. Now I'll try to show you one problem.
I have a question.
Yeah, sure. Go ahead.
When you were writing the previous current equation, would the angular frequency be 120 pi or just 120?
Okay, so omega is equals to 2 pi f. You have to remember this one. And as the frequency f is equals to 60 hertz, then we get it 2 pi times 60. That makes 120 pi. If I have written anything else different, then it's wrong. So whenever I'm expressing the current in terms of this, say for example, 20 cosine of 120 pi t. If I have written anything different, that's a mistake. So that was like minus 35 degree or something, right? So it will be 120 of pi t, not only 120, because this pi. Is it clear now?
Yes.
Okay. So any question to understand the phasor or any relevant question? I'll try to answer it. Now we will try to solve a very simple circuit. Okay, another important thing to remember here, very important, because in case I run out of time, don't be astonished whenever you face a different kind of circuit. And what is that different circuit? I'll tell you right now. Give me 1 second. So, for example, usually, the circuit elements are given in terms of sine wave, right? I mean, cosine wave. Like, say, for example, this is a circuit and given plus, minus, and this is Vt, and we have a capacitor here, and we have a resistor and an inductor here. Now, this is a 40 millihenry, and this one is 20 ohm. This one is 50 microfarad, and this Vt now is given in terms of 120 sine. Okay, I'll write it here in the below because I will not have such space. Vt is equals to 120 sine 377 t plus 60 degree volt. Now, how will you convert this into your non-vector form? like phasor form. This is not cosine anymore.
You have to subtract 90 degrees.
Okay, I'll subtract 90 degrees, then what? Okay, okay, you're right. So VT, so V is now 120 angle of 60 degree minus 90 degree, these forms. So anyway, if you see any sign here, like instead of cosine, because we have so far solved any circuit how whenever there is a cosine wave, but if it is a sine wave, you have to convert it back to 100 like in cosine wave first. So if you convert this into cosine wave, you have to subtract 90 degree. Anyway, don't forget to press your calculator to check it, like double check. So like sine 60 degree should be equals to cosine of minus 30 degree. If these two are similar, then you can really do that. Okay, so just like sometimes we make mistake, very silly mistakes. So check your calculator before doing that. And I'm hoping in your exam, like there is an exam, right? One exam left.
I believe next Friday.
Okay, so don't forget about this thing, right? So if you practice with sine, then don't forget about this problem, right? This kind of problem. Anyway, for this circuit, like we will try to find out what is the value of IT. Let's solve this one. If we want to find out, like say it is already given, like we have already converted this into polar form. I'm not writing it down anymore. Anyway, so think about it, is already given. Now, how will you try to find out this IT? At first, find out I equals to what? Okay, and you already have converted this V in vector form, right? So, what is the value of omega here? Just for your reference, like in case you face any quiz here, what is the value of omega?
You're 377 times 2 pi.
377 times. Okay, so omega is equals to 2 pi f, right? So is equals to 377. Now from this expression, you can find out like, okay, am I making any mistake? No. So omega equals to twice pi f. So 377 is equals to your omega, right? And from this expression, if it is asked to find out what is the value of f, like how much is the frequency, so you can convert, like from this expression you can solve for f, just 377 over twice pi, like 377 over 2 pi. These are kind of like small stuff, maybe you will ignore it, but in your exam you will see, you may see it. I'm not sure, but it is very possible to see this kind of thing, because Dr. Hasan usually like give questions from the very basic stuff. Anyway, now how will you find out this IT? So we will get I is equals to, so we know that, say for example, we know the V first, and then we have to find out the equivalent GT. This is conventional formula, right? This is the same formula. Now, how will you find out this Z equivalent? So to do that, we have to get what is the G in this branch and what is the G in this branch. That means G EQ is equals to kind of this capacitor GC, for example, we say GC, and then it is in parallel with that resistor, say for example GR plus G of L. So we have to basically find out this value. Okay. Now this is kind of, you know how to solve it, right? So GC is equals to 1 by j omega c is equals to, I'll solve it here. 1 anyway, kind of, it is it will take a little bit of time. So the basic idea is you will get something like here 30 degree, 30.96 angle of 9.239 degree. If you solve this circuit, like use your calculator, how you get this value. Now, once you get this value, this is in ohm. Don't forget to put the unit here. So you already know the vector form, I mean polar form of voltage here. Now, if you divide these two, you will get the current here, like 120 angle of minus 30 degree over this one, 30.96 angle 9.239. Now, once you go up to this value, then you will find out current is I is equals to 3.87 minus 39.9 degree, and unit is ampere. Don't forget to mention the unit. Now you have to convert it into like this time series format, right? So 3.87 cosine of minus 9.9 degree ampere. That's the pretty much basic. So for example, in some case you will see what is the value of V here, Vt here for only this portion. Now, how will you solve this kind of circuit? What is the direct way to find out this voltage? Tell me, anybody else? Say from this circuit you have already got your like the current I, you know your the voltage V 120 degree, sorry 120 angle of something, it was minus 30 degree, this volts. Now these volts actually this overall voltage, right? That means this total voltage is similar to this one. Now once you know the G value here, G of R, you know the G of L here. That means you know the total impedance and individual impedances, right? How will you find out this voltage, the voltage across V? Okay, so V of L is equals to what?
Would you use voltage division?
That's right. That's what I want from you. So voltage division rule, right? Because you have the total voltage, so VL vector form will be equals to like say I'm saying G of L times total voltage over GR plus G of L. So this will be your like the voltage across this one. Now, what is the voltage across this 50 microfarad capacitor? Any idea what is the voltage across this 50 microfarad capacitor in steady state condition, of course?
It's just your total voltage formula.
Total voltage. So why are you hesitating? This is a very simple and straightforward answer, right? Anyway, so now everything in terms of impedance we know how to solve, right? But in your question, in your exam, if you see something which requires you to find out in terms of admittance. Okay, I forgot to tell you one important thing. One important thing is that I told you what is the purpose of using inductors and capacitors in any circuit, right? So similarly, like the first circuit you saw, like say for example, you have a capacitor here, and you have a resistor here, and you have an inductor here. Just I'm making up a circuit. Now, what we can do here for the case of AC, as this is a time-dependent source, like Vt is equals to something like 120 cosine of omega t minus 30 degree, say. Now, what is the thing we can vary here? We cannot change t, right? Because t is automatically time varying, right? So what things we can change here? So omega equals to 2 pi f. So only thing we can vary the frequency, which is usually 60 hertz in case of AC, usually. Now we can vary this frequency in such a way that we can omit the imaginary part. Say for example, G is equals to like I'm just assuming this one will come into some value like some real part plus J some imaginary part, right? Now, if we can vary this angular frequency or this frequency and either one, we can get a point where this portion will become kind of zero. That means it is possible whenever there is a capacitor and there is an inductor. I told you the inductor gives you positive reactance and capacitor consumes that reactance because there is a negative sign. You see that, right? XL L equals to J omega L, but XC is equals to minus J over omega C, kind of, right? So what value J here, for example, giving some positive value here like 20 ohm, J 20 ohm, but for this one, maybe you are getting some kind of J 15 ohm. So what is the resultant value of these two? 5, right? Resultant value, if we add these two in series, then resultant will be 5 ohm. So what do you see from here? Inductor is giving positive reactance and capacitor is consuming that reactance, kind of. So resultant is now 5. Now we can increase or decrease this capacitor. We can modify this capacitance value, or maybe we can change the angular frequency omega so that these two quantities will be kind of equal. Whenever it will be equal, that imaginary part will be now 0 ohm. That is one important question you may face in your exam. For what value of angular frequency you will see this circuit as a purely resistive circuit. In that case, whenever there is no X, that circuit becomes purely a resistive circuit. Now you have to find out for what value of omega any circuit turns into a real resistive like circuit, purely resistive circuit. To do so, for example, for this circuit, what you will do, you will try to find out 1 over G equivalent equals to what? 1 over G equivalent is, okay, this one say for example, Z1, this one say Z2. You will find out 1 over G1 plus 1 over G2 because these are parallel, right? So at a point, you convert these values into something like that. So this is basically your admittance, right? So you will get something. So this one, 1 over GEQ is YEQ. Now you will see some value here I'm assuming like 0.1 plus J something in terms of like omega L x 1 over omega c in terms of something like expression here. Now we want to make this part equals to 0 because this one is G plus J B. We want to make this B equals to 0. So we want to make this B equals to 0. Now your target will be do not put any value of omega here for this expression. Do not put any value of omega. Then you will get an expression which contains omega in it. This omega. Now your target is to take this portion only and put it equals to 0. Only this portion. Then find out the value of omega. From this expression, you find out what is the value of omega in rad per second. So for this angular frequency, say for example, you are getting some kind of value here. For this angular frequency, this circuit will turn into a purely resistive. Say for example, for this angular frequency, we can convert this circuit into a purely resistive circuit, and you have to find out what is the value of this. Now, I told you how to find out this value. Any question? Maybe in your lecture, you have seen how to find out admittance. Now I will talk about admittance, a little bit of flavor of admittance. I know I'm running out of time. That I will take like a couple of minutes, like 2, 3, or 4 minutes. So I'll tell you what is the easiest approach to solve any complex circuit. For example, we have a complex circuit here, and you are asked to find out the admittances. Now, if you have a very complex circuit like this, resistance, inductors here, and then you have another parallel branch here, you have capacitor, you have inductors here, and then you have another thing here like resistor, inductors, and a capacitor here. And this is your final circuit. And what is the G equivalence and Y equivalent equals to what? Now, for this kind of circuit, the easiest way is to take this as a branch. For example, this is G2 branch, and this branch, say for example, as a Z1, and this is as a Z3, and this part assume as a Z4. Now, even if you are asked to find out what is the value of Y3, what is the value of Y4, always the easiest thing is to find out Z3 first and then invert it into this way to get the admittance. Okay. So if you are asked to find out what is the value of admittance in this part, although you know that admittances, whenever are in parallel, they added directly. If you convert this one into admittance, this one into admittance, then in parallel, they will just be additive, right? So if you face that is a difficult problem, then directly solve for Z first. Z equals to what? Then convert it into Y equals to 1 over Z. Maybe it is for equivalent total. It doesn't matter. So these two are these two are in parallel. Get a single value for here, like get a single value for here, something Z, get another single value for here, another Z3, and then these two are added because these two are in series. Now once these two are in series, if you replace these two branches with one branch here, you will get something Z here that is totally in parallel with this branch now. Now add this branch into some G2 value. Now this G is, say for example, 3, 4. So G3, 4 and G2 are in series or parallel? These two are in parallel. Now once you get these two in parallel, make another circuit, maybe replace these two into here, G total, G 2, 3, 4, and then this is in series with this one, this value, like this G1. Now you get the equivalent total and then convert it into Y equivalent, even if it is asked to find out Y equivalent. Like this is the easiest way I know. Anyway, if you have any question, please let me know or shoot me an email. I'll try to solve your problem. Of course, relevant to circuits analysis. But if there is no question, then thank you so much.
Thank you for your time. Have a good weekend.
You too. Bye-bye.